कैरेक्टरिस्टिक्स ऑफ अ स्केलर प्रोडक्ट। स्केलर प्रोडक्ट की कुछ कैरेक्टरिस्टिक्स हैं। इसकी पहले एग्जांपल थी, डेफिनेशन ये थी कि इफ़ द प्रोडक्ट ऑफ अ टू वेक्टर इज अ स्केलर क्वांटिटी देन इट इज कॉल्ड अ डॉट प्रोडक्ट और अ स्केलर प्रोडक्ट। Example of a scalar product is work and power. Work is a dot product of force and displacement, which is equal to FD cos of theta, and power is the dot product of force and velocity. So characteristics की तरफ आते हैं। characteristics of a scalar product क्या हैं? ये कुछ 5 से there are 5 or 6 characteristics of a scalar product, so which is I am going to read it. Scalar product is commutative. So first property is scalar product is commutative. It means that scalar product obey commutative law, and which is that a plus b is equal to b plus a. It is a commutative law of addition, and the multiplication is a dot b or a cross a dot b is equal to b dot a, which is a commutative. So scalar product of a two vectors obey commutative property. A dot b is equal to a b cos of theta, and b dot a is also equal to b magnitude of b and a cos of theta. So it is a first equation and it's a second equation. So by comparing first and second, we obtain a dot b is equal to b dot a, where a and b and a are vectors. So hence scalar product is a commutative. It is the first property, commutative law. It means that scalar property obey commutative law. Scalar product of a two perpendicular vectors. First of all, we read that scalar product obey commutative property, and second is perpendicular vector. Scalar, it means that the angle is 90 degree. Perpendicular means angle is of 90 degree. Scalar product of a two perpendicular vectors. If two vectors are multiplied by dot product plus scalar product, and the angle between those two vectors in 90 degree, then what will be the result? Final result. So here scalar product of a two mutually perpendicular. Mutually perpendicular means that they are perpendicular to each other. Both vector are vector A and B are perpendicular to each other, and the angle between them is 90 degrees. So it is saying that the scalar product of a two mutually perpendicular vector is 0. Why? Because angle is 90 degree, cos 90 is equal to 0. Consider two vector A and B making an angle theta with each other. I, J and K are the unit vector which show the direction having a magnitude of a 1. So A dot B is equal to a magnitude of A and B is equal to cos theta. So theta is the perpendicular, so we put here 90 degree. So the final result is 0 degree. Final result is 0. A dot B is equal to 0 if the vector are perpendicular of 90 degree. For perpendicular unit vector I, J and K, Ij. So we put Ij is equal to cos of theta. So Ij, Jk and Ki unit vector is also equal to 0. So if Ij is equal to if I dot j is equal to 0, so Ij, Jk and Ki also is equal to 0. So next properties is if two vectors are perpendicular, preceding case, and in the new case parallel. Parallel means the angle is 90 degree. Parallel means the angle is of 0 degree instead of 90 or of 180. So scalar product of a two parallel vector is equal to the product of their magnitude. Scalar product of a two parallel vector having an angle 0 degree to the product of their magnitudes. So consider two vector A and B having an angle 0 degree between them, so their dot product is equal to their product of their magnitude. So A dot B is equal to AB, because cos 0 is equal to 1, so that is the reason behind this.